the acceleration at any moment in time would be the limit for delta t goes to 0 for v measured at t plus delta t minus vt divided by delta t. So that is the instantaneous acceleration. And this, you will recognize, is the first derivative of velocity versus time, which is also the second derivative of position versus time. And so here comes the second equation that I really want you to remember forever and ever and ever, that the acceleration is dv dt, which is also d2x dt squared. We can go to our plot and we can ask ourselves the question now, where is the acceleration 0? Where is it larger than 0? And where is it smaller than 0? Because this value can be larger than 0, equal to 0, and smaller than 0. And now you have to be very careful when you try to derive that from this plot. You have to be very careful, because you and I have no good feeling for second derivative. Velocity is easy. All you have to do is looking at alpha. But when it comes to the second derivative, you have to see how alpha is changing. Well, right here, the velocity is not changing. So the acceleration everywhere here must be 0. Here the velocity is increasing. So the acceleration must be larger than 0 here. Here, the velocity is almost constant. It's almost a straight line. What does that mean for the acceleration? 0. Exactly. Here, when it makes this rounding curve, the velocity is positive here, but on this side it's negative. So what does that mean for the acceleration? Negative. You got it. And so you can now roughly find where the acceleration is positive, where it's negative, and where it is 0.